Good morning, everyone! Once again, this is your teacher Irene, and welcome back to my video lesson. Today, our topic is all about arithmetic means and the nth term of an arithmetic sequence. After this learning episode, you are expected to determine arithmetic means, find the nth term of an arithmetic sequence, and find the sum of the terms of the given arithmetic sequence. In the previous lesson, we defined what is an arithmetic sequence and find the next term of a sequence by adding a constant term. Let us have this example. Find the next three terms of an arithmetic sequence: 3, 8, 13, 18. The terms are a sub 1 equals 3, a sub 2 equals 8, a sub 3 equals 13, and a sub 4 equals 18. We are going to find a sub 5, a sub 6, and a sub 7. The common difference D in the sequence is 5. To get the next three terms, add 5 to each of the preceding term. Thus, a sub 5 is equal to a sub 4 plus 5 equals 18 plus 5 equals 23. A sub 6 is equal to a sub 5 plus 5 equals 23 plus 5 equals 28. A sub 7 equals a sub 6 plus 5 equals 28 plus 5 equals 33. Example number 2. Insert 4 arithmetic means between 5 and 25. Since we are required to insert 4 terms, then we will be 6 terms in all. Let a sub 1 equals 5 and a sub 6 equals 25. We will insert a sub 2, a sub 3, a sub 4, a sub 5 as shown above. We need to get the common difference. Let us use the formula a sub n equals a sub 1 plus n minus 1 times d. Let n equal 6 and a sub 1 equals 5. Substituting the given values for a sub 6 and a sub 1, we obtain a sub 6 equals 5 plus 6 minus 1 times d. Substituting the value of a sub 6, which is 25, we obtain 25 equals 5 plus 5d. Add the additive inverse of 5, which is negative 5, to both sides. So we have 25 plus negative 5 equals 5 plus negative 5 plus 5d. We obtain 20 equals 5d. Divide both sides by 5, d is equal to 4. Therefore, the common difference is equal to 4. Using the value of d, we can now get the values a sub 2, a sub 3, a sub 4, and a sub 5. Thus, a sub 2 is equal to a sub 1 plus d equals 5 plus 4 equals 9. A sub 3 equals a sub 2 plus d. 9 plus 4 equals 13. A sub 4 equals a sub 3 plus d. 13 plus 4 equals 17. A sub 5 equals a sub 4 plus d. 17 plus 4 equals 21. The arithmetic means between 5 and 25 are 9, 13, 17, and 21. The terms of an arithmetic sequence that are between the two given terms are called arithmetic means. What about if we are required to find the 100th term or the 250th term given the first term and the common difference? How can we find the terms? Using the process we previously discussed will take much of our time and effort. Before we find other higher terms of a sequence, let us first find lower terms. In the arithmetic sequence 3, 8, 13, 18, what is the 15th term? By adding the common difference to each of the preceding terms, we get the following values. Thus, the 15th term is 73. However, using this procedure to get any higher nth term would be tedious. Thus, a formula is necessary to find any nth term. Let us investigate on how to determine the nth term of a sequence. In the table, a sub 1 equals 3. A sub 2 equals 3 plus 5 equals 8. A sub 3 equals 3 plus 5 plus 5 equals 13. A sub 15 is equal to 3 plus add 5 14 times is 73. These terms can be written in the following manner as a shortcut. A sub 1 equals 3. A sub 2 equals 3 plus 5 times 1 equals 8. A sub 3 equals 3 plus 5 times 2 equals 13. And a sub 15 equals 3 plus 5 times 14 equals 73. Thus, if we find for the 16th term of the arithmetic sequence, then a sub 16 equals 3 plus 5 times 15 equals 78. Where 3 is the first term, 5 is the common difference, and 15 is one less the number of term. With this, we can derive the pattern that the nth term of the sequence is a sub n equals a sub 1 plus n minus 1 times d. Let us apply the formula in solving the following problems.
Problem number 1. Find the 21st term of the arithmetic sequence 6, 9, 12, 15. From the sequence, a sub 1 equals 6, d equals 3, and n equals 21. Using the formula, substitute the values. We obtain a sub 21 equals 6 plus 21 minus 1 times 3.
Let us apply the formula in solving the following problems. Find the 21st term of the arithmetic sequence 6, 9, 12, 15. From the sequence, a sub 1 is equal to 6, d is equal to 3, and n is equal to 21. Using the formula, substitute the given values. A sub n equals a sub 1 plus n minus 1 times d. A sub n is equal to a of 21. A sub 1 is equal to 6, and d is equal to 3.
A sub 21 is equal to 6 plus 20 times 3 is equal to a sub 21 equals 6 plus 60. A sub 21 equals 66. Thus, the 21st term is 66. In the arithmetic sequence 7, 10, 13, 16, find n if the nth term is 304. From the sequence, a sub 1 equals 7, d is equal to 3, and a sub n is equal to 304. Using the formula, substitute these values. We obtain 304 equals 7 plus n minus 1 times 3. Apply distributive property of multiplication, we obtain 304 equals 7 plus 3n minus 3. Simplifying terms, we have 304 equals 4 plus 3n. Add the additive inverse of 4 to both sides, we obtain 300 equals 3n. Divide both sides by 3, then n is equal to 100. Thus, 304 is the 100th term of the sequence.
What about if we are asked to find the sum of the sequence 1, 2, 3 to 100? How do we compute the sum of all the terms in this sequence? A famous story tells that this was the problem given by
Elementary teacher
to a famous mathematician to keep him busy. Do you know that he was able to get the sum within seconds only? Can you beat that? His name was Carl Friedrich Gauss. Do you know how he did it? Let's find out by doing this activity.
What is the sum of each of the pairs 1 and 100, 2 and 99, 3 and 98, 50 and 51? How many pairs are there in number 1? From your answers in number 1 and number 2, how do you get the sum of the integers from 1 to 100? What is the sum of the integers from 1 to 100? Here is the derivation of the formula for the sum of the n terms of an arithmetic sequence. Denote the sum of the first n terms of an arithmetic sequence by S of n. Rewrite the sum in reverse order, we get this equation. Rewriting the two equations above using their preceding terms and the difference d, we have equation 1 and equation 2. Adding equations 1 and 2, we get this equation. Since there are n terms of the form a's of 1 and a's of n, then 2s of n is equal to n times a's of 1 plus a's of n. Dividing both sides by 2, we have s of n equals n over 2 times a's of 1 plus a's of n. Now, since we have that a's of n equals a's of 1 plus n minus 1 times d, then by substitution, we have s of n equals n over 2 times 2a's of 1 plus n minus 1 times d. To find for the sum of the arithmetic sequence, we can use s of n equals n over 2 times a's of 1 plus a's of n, or s of n equals n over 2 times 2a's of 1 plus n minus 1 times d.
Example number 1. Find the sum of the first 20 terms of the arithmetic sequence 9, 15, 21, 27. Let us solve first for the common difference. The common difference is given by a's of 2 minus a's of 1. What is a's of 2? 15 minus 9. The common difference is equal to 6. Since we already have the common difference, we can now solve for the 20th term, given by the formula a's of n equals a's of 1 plus n minus 1 times d. So, 20th term is a's of 20 equals, the first term is equal to 9 plus n is 20 minus 1 times the common difference, which is 6. So we have a's of 20 equals 9 plus 20 minus 1 is 19 times 6. A's of 20 equals 9 plus 19 times 6 is equal to 114. Therefore, the 20th term of the sequence is equal to 123. And now, we can now find for the sum of the first 20 terms of the arithmetic sequence given by the formula s of n equals n over 2 times a's of 1 plus a's of n. Substituting the given values, s of 20 is equal to 20 over 2 times a's of 1 is equal to 9 plus a's of n, or the 20th term, is equal to 123. So, s of 20 is equal to 20 over 2 times 9 plus 123 is 132. This is now equal to 20 times 132 is equal to 2,640 divided by 2. Therefore, the sum of the first 20 terms of the sequence is equal to 1,320. Using the formula s of n equals n over 2 times 2a's of 1 plus n minus 1 times d, we can also find or get the sum of the first 20 terms of the given arithmetic sequence. Substituting the values of n, a's of 1, and the common difference, we have s of 20 equals 20 over 2 times 2a sub 1 is 9 plus n is 20 minus 1 times the common difference, which is 6. S of 20 is equal to 20 over 2 times 2 times 9 is equal to 18 plus 20 minus 1 is 19 times 6. S of 20 is equal to 20 over 2 times 18 plus 19 times 6 is 114. S of 20 is equal to 20 over 2 times 80 plus 140 is 132. S of 20 is equal to 132 times 20 is equal to 2,640 divided by 2. Therefore, the sum of the first 20 terms of the given arithmetic sequence is equal to 1,320. At example number 2, find the sum of the first 16 terms of the arithmetic sequence 8, 11, 14, 17, and 20. The given are base of 1 is equal to 8. Base of n is equal to 16. And then d is equal to 11 minus 8 is equal to 3. And we are going to find for the sum of the first 16 terms of the arithmetic sequence. So the last term is not given. We are going to use the formula S of n equals n over 2 times 2a's of 1 plus n minus 1 times d. Substituting the values, we have S of 16 equals 16 over 2 times 2 times what is a sub 1 is 8 plus n minus 1 is 16 minus 1 times the common difference, which is equal to 3. S of 16 is equal to 16 over 2 times 2 times 8 is 16 plus 16 minus 1 is 15 times 3. So S of 16 is equal to 16 over 2 times 16 plus 15 times 3 is equal to 45. S of 16 is equal to 16 over 2 times 16 plus 45 is 61. S of 16 equals 16 divided by 2 is 8 times 61. S of 16 is equal to 488. I hope you have learned something new today. Please do not forget to like and subscribe in my YouTube channel. Bye-bye!